Hello Python and welcome to your 12 Python tutorial. In the last video, we looked at comments in Python. In this video, we are going to look at operators in Python. Operators in Python are used to perform operations on variables or values. Variables in Python reference values, as we already know, and these could be numbers, int, float, or string, and then so on. But in this video, we'll look more at working with numbers, so integer, float, and then so on, and we'll see the different kind of operations that can be performed on these variables or values. There are several types of operators in Python that perform different operations. They are grouped into 7. We have arithmetic, assignment, comparison, logical, identity, membership, and then bitwise operators. We are going to take a look into what these different operator types can be used for. Now let's take a look at arithmetic operators. Arithmetic operators are used to perform basic mathematical operations, so addition, subtraction, multiplication, and then division. So they are one of the most used operators that you'll be using. One of the most used operators, especially when you are doing basic mathematics. Let's switch to our code editor. See something in action. So I have a Python file called arithmetic. And I'm working with two variables. So one has value 30, A, and then B. 20 is assigned to B. So I can add the numbers. So I can use basic operation like a plus, addition, and then so on. So I will switch over back to my slide. And first of all, let's take a look at some arithmetic operators. So addition, which basically add numbers, subtraction, subtract numbers. We have multiplication to multiply numbers. Then we have this division, which divides two numbers. So A and then over B, and this retains the numbers plus, the whole number plus the decimal values. Then you also have the modulus. So what modulus does is that it performs division and returns to you the excess of the division. So you divide two numbers and it returns the leftover. Then you also have exponentiation, which is basically a number raised to the power by another number, so A raised to the power B. So this is how it is denoted. And then all you do is that that means that A is going to multiply itself B number of times. Then you also have floor division, which returns the whole number, leaving out the excess or the decimal place values. So back to our code. And we have that in action. So we have A plus B, A minus B, A times B, A divided by B to perform a normal division. Then we have floor division, which returns the whole number, leaving the excess values. Then you also have the module, which returns the excess value, which returns the excess value. So, and then exponentiation. So let me quickly run this file and then see what we get. So I've run this file. So let's quickly go through the results. So we have A plus B giving us, A is 30, B is 20, A plus B giving us 50, A minus B giving us 10, A multiplied by B giving us 600, then A divided by B, that's divided by B, giving us 1.5. Now A divided by B, this time floor division, and then it returns 1. So basically what it means is that A can go to, so it's A floor division B, so that means that B, which is 20, can go into A, which is 30 once. So that's why we have that whole number 1. And for the modulus, A modulus B, so what basically means that A goes into B, so A goes into B once, okay, so, and then the remainder, or the number remaining, is 10, okay, so dividing 30 by 20 initially would give us 1 and then a decimal value. So we are not looking at the decimal value, but we are looking at the leftover, the remaining number that could not be divided by B because they are not up to the number B. Okay, so you get that. So you have 10, and then finally we have exponentiation, which gives us this value. Okay, so basically saying that A multiplies itself like B number of times. Okay, so you multiply A by itself 20 number of times, which is B. Okay, now let's move to the next operator, which is the comparison operator. Basically, a comparison operator is used to compare two values and returns true or false based on the result. So it's A equals to B, is A greater than or equals to B, is A less than or equals to B. Okay, so based on the results, the return is either true or false. So comparison operators can be equals to, not equals to, greater than, less than, greater than or equal to, less than or equals to. Let's see that in action in our code. So I'll switch over to my file called comparison. So then again I have A and B. What I'm doing is that I'm comparing A and B, whether they are the same value. Then I'm also going to find out whether A it's not equals to B. So let me run my code and then I will explain the results. Okay, so A equals to B. Okay, so this is not an assignment, so this is comparing A and B, okay, side by side, and it gives us false. Why? Because A, the value of A and the value of B in memory are different, and so we have false. And then not equals to will give us true, because of course A and B is not equals to. And then we can also compare if A and A is greater than B, which gives us true. A is less than B, which gives us false. Then A is greater than or equals to B. Okay, so A being 30, okay, is greater than B, okay, but it's not equals to B. Okay, so once it's greater than satisfies that, it gives us true, so greater than or equals to true. And then A is less than or equals to B. So A it's once again 30, and then B is 20. So A is not less than B, neither is A equals to B, and so that should also give us false. So that is for the comparison operator. Logical operators connect two conditions and perform an action when the logical expression is true or false. Okay, so unlike the comparison where we could compare two values, logical operators, we mostly use them when we are comparing two expressions. Okay, so A is equals to B, and then A is greater than or equals to B. So these are two different expressions, and to be able to perform a logical expression, you need to use a logical operator. So we have AND. Now AND returns true, so logical operators also gives us true or false depending on the results. So true, AND gives us true if both expressions are true, or gives us true if at least one expression is true, and then the NOT gives us true if the compound expression is false, and then gives us false if the compound expression is true. So it gives us the reverse. Let's quickly look at that in action. So I have a file called logical. Okay, so I'll open that. Okay, and I will run like I do always, and then so I'll run like I do always, and then I'll try to explain the results to you. So I have three variables this time around. A is 30, B is 20, and then C is 15. So I have two different expressions. A is greater than or equals to B, and then C is greater than or equals to B. So I want to perform a logical operation on these two different expressions. So taking AND, we learned that AND logical operator will return true only if all expressions evaluate to true. So in the case of this, a is greater than or equals to b, it is true. Okay, but c is greater than or equals to b is false, because c is 15 and then b is 20, and then it's clear that c cannot be greater than b, and at the same time it's also not equals to b. So this gives us false value. Okay, and that's the reason why we have false over here. Okay, then we use that same two expression. This time we are using the logical operator or. Now the rule is that or will evaluate to true if at least one of the expression on either side is true. And in this case, we know that the first expression is true, but the second expression is false. But because the first expression is true, then it returns true. So we are using the same set of expression, but this time we are using the not. So we are going back to the AND operator, but this time we are using the not. So the AND operator initially gives us false, but because we are using the not, we are getting the reverse, which will give us true. And then same thing for the OR operator, which give us true, and because we are using the not, we are getting the reverse. Okay, so that is the difference. Just take note. Okay, so that is that with logical operators. Identity operators check if two variables point to the same object in memory and returns true or false. Now, in identity operators, we are not looking at values. Okay, so the two values can be the same in form, they can be the same in appearance, but if they are not the same object, or if the variable that we are comparing is not pointing to the same object, same means exact, identical. I mean, it's exact. So if it is not exact, then it's going to give us false. So if we have a to be 5 and b is to be a, basically what it means is that a is the same as b, because b here is equals to a means a object is assigned to b. Okay, so it means that it's the same thing. So my name is Stephen Efriye. So Stephen is me, Efriye is me. So I'm the same person. Okay, if you compare me to another person, even if that person is my twin, identity would not work here, because it has to be the same. So now let's see that in action. I'll open my identity Python file. So over here I am using an array, a list. Okay, so a is assigned to a list 1 2 3 4 5 and 6, and b is assigned 1 2 3 4 5 and 6. So now looking at this, you could say that they are equivalent. Okay, so kind of they are equivalent, but in the case of an identity operator, okay, let me now run the file first. So I'll run. Okay, so interestingly, a and b, okay, so they are assigned with basically the same values, and then c is assigned to the object a. So when we ask if a is c, Python tells us that is true. Okay, so c is assigned to a, I mean a is assigned to c, so they are the same object. But when we find out so before I come to the s not, let me ask. Okay, so I'll just say print a is b. So can you guess what would be my results? Okay, so let me run. Okay, and it tells me that it's false. Even though a and b have the same value, they are not identical, or they are not pointing to the same value in memory. They have the same value but different memory locations, and so they are not the same object, and so it gives me false. And a is not c, of course, you are asking if a is not c, as in terms of the identity operator, which of course makes sense with the false results. Okay, I mean it gives us the false. Why? Because so with the not, okay, it's not. Okay, so it's not asks if a is not b. So if a is not identical, if a doesn't have the same object as c, since a has the same object as c, then it tells us that this is false. Why? Because a has the same object as c, and so if you say a is not c, then it is really false. Okay, so that has to do with identity. So we look at the identity operators. Membership operators check if a value is contained within a sequence and returns true or false. Okay, so if you have a list 1 to 5, then you can check if 1 is a member or B is a member. So apart from using it on lists, you can use it on strings and then so on. Let's quickly look at code in action. So I'm going to open my membership Python file, and then I have a list 1 to 6, 1, 2, 3, 4, 5, and 6, and then I have a variable B which is 6. So I can check if B, which is 6, is a member if A, and then you could also find out if it is not a member by using the not in. Okay, so let me quickly run my code, okay, and let's see what I get. So A is a list here 1, 2, 3, 4, 5, 6. B is 6. So if I check if B is a member in the sequence, which is true. Why? Because B is 6 and then 6 is a member of the sequence. Okay, so it's checking the values. Okay, the values. So what if B is 7? Okay, what if B is 7? And I want to find out if B is a member of A. When I run this, it should give me false. Why? Because B, which is 7, is not a member in this list or this sequence. And then I could also use not in. So not in, I want to find out if indeed a value or a variable is not a member of a sequence or a list. Okay, which is this case. Okay, so B not in A, and then I get true. So that is that. So if you look at membership operators, so in true if a value is found in the sequence, and then not in true if a value is not found in the sequence. A bitwise operator converts integers to their binary equivalent and perform bit-by-bit operations on them, hence the name bitwise. Okay, so you have an integer value and you do a bitwise operation on it. So the integer values are going to be converted to binary, and 1, 0, so bits, and then it will perform the bitwise operation on each bit, so each ones and then zeros, and then it is going to return you your results. Okay, so these are the bitwise operators. So you have the bitwise and bitwise or bitwise not, bitwise right shift, and then bitwise left shift. So if you work with binary numbers, you'll be using it most of the time. Let's switch over to my code, and then I'm going to open a file called bitwise. Okay, so bitwise.py. So A is equals to 10 and then B is equal to 20. So I can perform a bitwise and a bitwise or XOR, and then not XOR, and then so on. Okay, so you need to know the binary equivalent of the numbers, okay, before you can be able to perform the bitwise operation. That is what Python does for us. Okay, so I can run my code. Okay, I can run my bitwise code, and then I get my value. So notice that I get my values here. Okay, so 0, 30, -11, and then so on. Okay, finally, let's look at assignment operators. So assignment operators are very easy, straightforward. Okay, so they are basically used for assigning values to variables, and as soon as you start working with variables, you start working with assignment operators, because without assignment operators, then variables cannot be created and values cannot be assigned to variables. Okay, so basically you have the equals to, single equal to sign, and you have seen all these operators. Okay, so multiplication, division, modulus, and then all that. So you can have these assignment operator. Now you would see this thing most of the time, especially when you see it several times in a lot of codes. Okay, especially when you're performing maybe an if while a while loop, and then you need to increment. You can use, instead of saying a is equal to a plus, you can use, so they are more like shorthands. Okay, but of course you are not under any obligations to use them. If it sounds confusing at first, you can decide not to use them, and then when you are more clear with it, you can start using them. Okay, so there are a number of them. Okay, for almost every operator, you can use this shorthand assignment operators, and then so on. So guys, thank you for being part of this video. Hope you learned a lot, and I'm going to see you in the next video.